Coming back to our stereoisomerisms. Stereoisomerisms, the example of EZ isomerism and the optical isomerism. Now, EZ isomerism, this is known as the cis and trans isomerism, where the E refers to the trans and the cis refers to the Z respectively. Now, optical isomerisms. We talk about our optical isomerisms. What are optical isomerisms? Well, basically, there are two types of the particular isomers, which are formed, which cancel each other out in plane polarized light. Now, what is the meaning of plane polarized light? Well, if you remember in the physics chapter, we talk about polarization. When we consider our Polaroid, a function of Polaroid is to only allow the actual process of polarization involves the allowing or passing through of light of one particular wavelength, and then you can say that it's restricting the flow of light respectively, therefore decreasing the intensity of light, turning the unpolarized light into polarized light. In other words, allowing the passage of one particular wavelength of light respectively. Now, when we come to optical isomerisms, actually the optical isomerisms possess a chiral center. The meaning of a chiral center, or you can say the stereo center, in other words, actually involves the bonding of the four different groups to that chiral center of the carbon atom, or the stereo center of that carbon atom respectively. The pairs of obviously the two isomers, which are said to be chiral, are known as the enantiomers. Now, moving on to which we'll be talking about, is our synthesis of the 2-hydroxypropanoic acid, and then we'll be talking about the applications of the optical isomerisms in the drug industry. Basically, this is we're going to talk about the synthesis of the optically active compounds. So basically, active compounds produce a 50-50 mixture of two particular isomers. This is known as a racemate mixture, or the racemate. It's either known as a racemic mixture or a racemate, and is not optically active because the effects of the two isomers cancel out each other. In other words, they cancel out each other's polarity, which you would have studied L and D form. One is levorotatory and one is dextrorotatory. Dextro referring to right side turning in the plane polarized light, and levorotatory referring to the left plane polarized light. So basically, we come now to the synthesis of 2-hydroxypropanoic acid, which is known as our lactic acid. Basically, stage 1 is where our compound, which is our ethanol, is attacked which undergoes the process of the nucleophilic substitution reaction, which leads to the formation of our 2-hydroxypropanenitrile. This 2-hydroxypropanenitrile then further undergoes the stage 2, whereby it is attacked by the HCl plus H2O, giving us our final compound, which is our 2-hydroxypropanoic acid. Basically, the mechanism of this, in other words, how it is formed, the double H double bond respectively, we will have a look at that in detail. Basically, as we know that the common reaction of a nitrile compound here, if example I'm taking out ethane nitrile, this will form under the reaction of water. When water is added to the nitrile compound, this will form the carboxylic acid. And this carboxylic acid in this case is known as our ethanoic acid. Now you move on to our last topic, which is known as the optical isomers in drug industry. Now basically the optical isomers is very, very important. Basically there are three aspects which you can observe. Optical isomerisms can be used to form a particular drug. In other words, forming a particular isomer can lead to a generation of a particular drug. It can lead to, in the case of our racemates, which are actually cancer, or you can say that one particular isomer may be useful, the other one may prove to be toxic. Now this is an example of our ibuprofen. Obviously, ibuprofen is used to treat our muscle pains, or basically it can be an anti-inflammatory response as well, drug for that. But there's another one which is neuroprene. Neuroprene is actually an isomer which is formed of the actual ibuprofen that is used to treat our arthritic pains. But another isomer which is formed, the optical isomer of the neurophene, actually causes liver poisoning, so it has to be very, very careful. That's why when designing drugs, that the correct isomer is formed and chosen respectively.